Okay, thank you. So today we're going to talk about containerization. So let me give some introduction about it. Before that, let's see some history behind how the machines are evolved. Okay, how the computers are evolved. Okay, so initially we used to have a computer, or you can call it as a machine. Okay, and this typically used to have CPU and memory. Okay, and blah blah blah, all this stuff, right? So now what you do it, on top of it you will install a operating system. Okay, and then you make use of it, then use it. So this is how the conventional computer has been evolved. Okay, then after that, once the technology revolution comes into the picture, the software industry, and entire the software, not the computer, this computer is a hardware part. So once the software came into the picture, and once the web came into the picture, internet, so we started hosting the servers. Okay, so when it comes to the servers, right? Okay, we keep n number of servers. Okay, a server nothing but an entire machine. Okay, entire machine. So this entire machine, this kind of n number of machines, we keep it in one location, and that location we call it as a data center. Okay, so in a data center you have n number of servers, right? So this is how the data centers were maintained in the earlier days, and your job is to connect to these servers and deploy the application. Okay, and each and every server, when I say server, one server, okay, will be having a designated CPU power, as well as a memory. Okay, as well as the hard disk space, whatever. Okay, so everything is designated, so you can just deploy only the certain set of applications, not more than that. Okay, and suppose, think about your software requirement. Okay, when it comes to your software, when you release the 1.0 version, okay, you required only 2 servers. Assume this is in 1999. Okay, then after that you got more business from the customers and all. You nothing but the client. Okay, and he started developing the more features, so he started releasing the second version. Okay, and for the second version he increased the number of services, number of uh, customizations of his application. So he might need some 4 servers. Okay, maybe in the 2000 year, right? So then after that, he got more response from his customers, and he got n number of his customer base or user base is increased, and now he might need 20 servers. Okay, so in 2001, so you know what, gradually as the software demand is increasing, okay, and even to run that software, okay, the hardware demand is also keep on increasing. Okay, but you are not understanding the thing is how tough it is from bringing an application deployment from 2 servers to 4 servers, 4 servers to 20 servers. This is called scaling. Okay, scaling nothing but scaling based on your requirements. Okay, and this is not dynamic in those days. We used uh, to bring the other extra servers, right? Okay, you need to put a purchase order, okay, to buy a server, right? And for the purchase order you need to get it built, and you bring the software, you need some people to bring that into the data center, and you need to install the OS. Okay, and then you need to install the softwares. Okay, and then you need to deploy your application. Okay, there is so much of processes there to bring up a new server into your data center. Same thing when it is 20 servers. So as this is keep on increasing, right, the complexity of hosting the application or servers is really cumbersome activity and expensive activity. Okay, for companies and all. So think about a startup is there. Okay, they don't have much investment. 4 people joined, they got an idea and they wanted to start a company. Okay, and they wanted to bring up an application. So for them, right, assume they have some $100. Okay, in $100 they can maximum spend on one server. Okay, they can maximum spend on one server, but for their software requirement they might need around 20 servers. Okay, they don't have a budget. So what happens, they can't develop their application. Okay, they can't host it. See why I'm saying they, with the least budget. Okay, if you wanted to develop a software, it's really difficult, because hosting a 20 servers in a data center is nothing but it's very expensive activity. You need to have a space and 24 by power. Okay, and you need to have people should be maintained. You need to have a 24 by 7 broadband, and somebody should monitor it. Okay, and somebody should check the health checks and all. So this is where cloud came into the picture. Sorry, virtualization came into the picture. Okay, virtualization. So with virtualization, what happened, Earlier the problem here is people needs to purchase each and every individual servers. Okay, so if a diagrammatical way, then it is really nice to understand. Okay, so earlier we used to have like n number of servers like this. Okay, so put cables to all the servers and bring them into a network. Okay, and all of them into one network, right? So this is in a very olden days. Then after that there is a big revolution came into the market, which is a virtualization. Okay, with this virtualization what happened, so when they're spending like around $100 on each server, right? Okay, like they might need like $400 to like purchase 400 servers. After virtualization came into the picture, what they were doing, like they are buying a high-end configuration server, one server. Okay, and this server, with the help of the virtualization, they can create, with the help of the virtualization software, right? Okay, they can create multiple VMs. Okay, like this is one VM and this is one VM and this is another VM. Okay, so for end user nothing but you and me, whoever. Okay, assume like we are the end users. For us, these machines are individual machines. Okay, they have a dedicated IP address, they have a dedicated CPU, dedicated operating system. See, again in this VMs, right, you can host whatever the operating system you want. See, first VM you can have a Linux, and the second VM you can have a Windows. Okay, and third VM you can have like some other Unix. Okay, and every machine have the computing speed and memory and hard disk, everything. Okay, just like how they were there earlier in like over here. Can you see this? Okay, so here everything is independent, right? So something like that we can create within one machine, one hardware. Okay, so this is only one hardware component. Assume like some 16 GB RAM, 2 terabytes hard disk and all. So with on this machine, so we'll purchase a one high-end server, and that high-end server we can partition into like n number of virtual machines, and these virtual machines we can make use of in our real-time world, and we can keep like in a data center, right? Assume like I need 100 servers. Okay, if you want 100 servers, nothing but 100 nodes you want it. It's not server. Okay, so call it as a node or VM. So if you need 100 100 VMs, right, you try to purchase only like uh, 10 servers, 10 high-end servers. Okay, when you purchase 10 high-end servers, each high-end server they can make it to 10 partitions. Okay, and this 10, maintaining a 10 servers is easier than maintaining 100 servers, right? So that's the virtualization concept came into the picture in 2005, 6 and all. Okay, so with that, what happened, most of the data center uh, what do you call, the cost of the data center, okay, the maintenance of the data center got a bit reduced, okay, compared to the earlier state. So only the big servers like manufacturing servers, they used to purchase it and they create a VM and they provide all these VMs to the people and we like access them. Okay, even this, okay, is a big burden for startups. Okay, this is okay for medium scale companies. Okay, so even this like purchasing this one server, don't think like 16 GB 2 terabyte site machine server will come for like 50K and all. Okay, you don't get for 50K and all. Some like like you and me, people are there, we are fresh new graduates from the college, and we have an idea, we want to implement it, and for that we need a server. Okay, so we cannot afford even this 50K for this single server also. Okay, so for those kind of people who cannot afford the server, even you can afford also, see, this still have the problem of like maintenance. Maintenance is nothing but power, broadband, okay, and also some space, office space. Okay, and something like administrator, you need somebody to look into it. So see, even if you can afford this server also, but you cannot afford this the rest of stuff. So what is happening, after that, see, by looking at this requirement, many startups requirement, most of the good companies, big companies, they come up with a revolution called cloud. Okay, what exactly cloud is? They made this use of virtualization, okay, in the cloud. So what happens, uh, in uh, in a cloud, right? Okay, cloud nothing but it's again another data center, guys. Okay, only thing is this is owned by some company, ABC company. Okay, some ABC company. So this ABC company, what they will do it, if somebody like you and me are there, okay, what we want is we need a VM, okay, and we don't want it to pay much, okay. I have only $1 with me, okay. I have only $1 with me, so I just want this server for only for 1 day, okay. So you want a server for 1 day up and running, okay, and you have only $1, okay. So with this budget and with this time, see, you don't want the server to be permanently for you, okay. With this budget and with this time, you cannot afford this one, okay. This is quite impossible, okay. So with cloud coming to the picture, you can afford the same server, okay, for 1 day, which is possible here. You might be thinking how it is possible, okay. What exactly this ABC company is doing, they run a business called they host a data center, okay, within their space or wherever it is, okay. So what they will do, they have n number of servers. They procure n number of servers already, okay, the hardware, right. They procure a number of servers. Now when you request, right, so they would have developed some UI for you, okay. They would have developed some UI nothing but an application layer, a web page, okay. So in this web page you request them, okay. So when you request them, so when you're requesting, you request with some inputs, right. So I need a server with 1 GB RAM and 30 GB hard disk, okay, and something like what do you call 30 GB hard disk, okay, 2.2 gigahertz processor, okay. I need a VM with this with this data, okay. So I need a VM with this configuration. So when you feed this input, right, so what they are doing in the back end, they have a core servers, okay. So they were running a virtualization software in the background, okay. This is a virtualization software, okay. So they run a virtualization software in the background, and with the help of the virtualization software, whatever the inputs you give it, right, okay, these inputs they give it, they process it in one of the server, and they prepare a machine, okay, a VM, and they'll assign an IP, and all this, once it is done, it will immediately reply back to you saying like, here is your VM and you can access it. That's it, okay. And they maintain some logic in this virtualization software, or they're in the application layer. So you paid for only for $1, you paid only $1 for 1 day, right. So they will wait for this 1 day to be completed, okay, and they'll alert you saying like, if you want to renew for next day, you can renew it, or next 1 month you can renew it, okay, by paying $30, or for 1 year pay $365. If you don't want to renew, right, if you just leave it, right, what this software will do, it will decommission, okay, this VM and make it free. So you cannot make use of this VM again, okay, after 1 day. So nothing but it's on demand. Based on a demand, he is creating something on the fly and giving it to you, okay. So think about like, like you, there are n number of people in the market, okay. There are n number of startups, or like, n number of people are there. Those people are all like, they want some machines to be there to perform their task and their POC, their project for certain time, not for completely like, permanently, okay. So in those scenarios, this company can make utilize of all these people's requests, and they can make a business. So now this guy is getting benefited. Now whatever the money he charged, right, he just spending on only on procuring the hardware, and the same hardware is like, he's keep on renting it. Actually what he is doing it, he is renting you the server, okay, renting the servers, right. So and again he's renting the servers with the software, okay, with the help of a software. So this ABC company, you can treat it like, all your cloud companies. The most popular company in the market right now is the AWS and Azure, okay, and like, the Google Cloud. So all these people are doing this business only at the moment, okay. So on-demand hardware or on-demand VMs, okay. So this is a virtualization concept, right. Now the world is keep on changing, okay. Now I hope you remember like, we were also creating the virtual VMs actually in our laptop, okay. If you look at like, treat it, this is a laptop, okay. There's no cloud, nothing, and also what we did it, we installed a VirtualBox software. The VirtualBox is a virtualization software. So we installed a VirtualBox software, and we created a VMs with the help of a small software called what? Vagrant, okay. See, think about this layer is a Vagrant. What I'm doing, okay. This thin layer between your virtualization software and your VMs is a Vagrant. So this Vagrant is helping you, okay, This vagrant is helping you to create the VMs. Okay, so it's a kind of intermediary. Same stuff here. When you insert some when you give inputs to your virtualization software, right? Okay, the AWS Azure guys, they have their core logic behind it. Okay, they have their core logic, another layer. Okay, treat this layer like, their vagrant. They don't use vagrant, but in backend they have their own software which creates the VMs. Okay, so some background software. Okay, so which creates the VM. So whatever these guys are doing in the cloud, right, same thing we are doing in our laptop. This is what our laptop guys. Okay, so now this is what the VM concept. Okay, I hope you understand. A VM, a virtual machine, okay, is like a full-fledged server. Okay, full-fledged server. So what exactly I'm trying to say is, see, it is not like, kind of a tiny software and all. It has a CPU, it has a memory, it has everything. Okay, a VM is like, full-fledged software. That's called a VM. So how exactly the VM look like? So you have a hardware layer, you have a hardware layer. Okay, and on top of it you have a software layer, sorry, OS layer. Okay, once OS is done, then this is what your application, this is what your application layer. Okay, app or software layer. Okay, so this is what in a VM actually. Okay, and again, to spin up this VM, right? Okay guys, how much time you spend on spinning up a VM guys? Okay, you might be run through vagrant, right? It takes some time. Okay? It's not that easy to like, spinning up a VM actually. Okay, to start and stop a VM, it takes like, 5 minutes to some 10 minutes, depends on like, your broadband speed and all. Okay, now even this virtual machine, right? Okay, this assume like, this is a part of your bigger machine. Okay, so assume this is what your laptop, this VM is like, part of your bigger machine. Okay, now what happens, you may need like, some 10 VMs. Okay, so if you try to create 10 VMs here, right? Okay, like keep on create some 10 VMs. Okay, right, what will happen, the performance of each and every virtual machine will be degraded, and even your full performance of your entire machine will be degraded. Okay, nothing but every VM will take the computing speed, the memory, okay, the hard disk, everything, it will share it actually. Okay, so when assume like, your total memory, your total machine memory is 10 GB. Okay, if each and every machine is sharing a 1 GB, think about like, the speed, the performance and all. Okay, it is completely degraded, and to spin up and spin down each and every machine, it takes more time. Okay, and if the number of instances are increased, right, that's it, the performance will be gone. Okay, so this is one of the problem with virtualization. It's not a problem, it's a limitation of the virtualization. Okay, so this is what the virtualization can do it. Now the next generation technology, okay, which is containerization. Okay, so what exactly a containerization is? This is important guys, try to understand the difference between a virtual machine and a container. Okay, this is an important question. If somebody, if you say somebody like, Docker and all, they'll definitely ask you this question. What is the difference between a virtual machine, a container? So let me explain you a container. Okay, so what exactly a container is? See, let me just wipe out this part. How can I clean up all together? If it is a whiteboard or blackboard, it is really nice to explain all these topics. This paint is too tough. Okay, so what exactly a container is? See, you will have a machine as usual, your laptop or whatever. Okay, and sorry, you install an operating system. Okay, this is your core operating system guys. Okay, operating system. Okay, and on top of it okay, you will be installing a tool called some engine, okay, container engine. Okay, so you install a container engine. Now with the help of this container engine, what you will do it, you will spin up the VMs, virtual machines. Okay, and again I'm calling it as a virtual machines, but actually these are not virtual machines, these are containers. Okay, why I'm saying containers is because all these containers will make use of same hardware, guys. Okay, see below this you have another layer called hardware. Sorry. Okay, hardware. Okay, so all these containers will make use of your same hardware. Okay, so nothing but what is happening, it's same hardware, nothing but whatever the operating system you're running, right, on top of whatever this operating system is designated. Okay, assume like this operating system is designated 4 GB. Okay, and all these containers will make use of this 4 GB RAM for their containers to be running. Okay, and again running these containers will happen like within few seconds. Okay, within 2 seconds you can spin up a container. Within 2 seconds you can spin up a container. Okay, but when it comes to a VM, okay, it takes some minutes. You remember like when you do the Vagrant up for first time, how much time it takes? It should go through the boot process. Okay, there is a boot process here when you're trying to spin up a VM machine. Why boot process? Because you're trying to install an operating system for each and every virtual machine. So what I'm trying to do it, what I'm trying to say is, in this VM, right, you have a OS. Okay, and again in this VM you have a OS, you have a OS, you have a OS. So you have OS everywhere. Okay, but when it comes to the containers, they have a very basic OS. Okay, and that will share your container engine, and the container engine will provide the whatever the hardware you have it in your core operating system, and with the help of that it will survive. Okay, so let me try to show you a good diagram in the Docker website. Okay, just a second. Virtual machine versus container. Yeah, this should be a nice good diagram. Okay, guys, can you see this? Two servers. Okay, containers versus virtual machines. Okay, you look at this. The first one is a virtual machine. Can you see this virtual machine? In a virtual machine, hypervisor is a virtualization software. Okay, hypervisor is a virtualization software. Okay, with the help of this software, what we will do, we create a VMs. Now 3 VMs somebody is created here. Okay, so guest OS nothing but here you can put Linux or like Unix, whatever. Okay, 3 OSs. This is a conventional virtual VMs creation. Okay, and when it comes to the containers, right, look at this. There is no operating system for each and every container. It makes use of the host OS. Can you see this host OS? So whatever the OS you have it in your server, right, okay, that OS it will use it. So that's the reason the containers are very lightweight than the virtual machines. Okay, as these are lightweighter, okay, they can spin up within few seconds, and like we can stop within few seconds, and it is really easy to like spin up n number of containers. You can keep like 10 or 20 containers within one machine, but if you keep 10 VMs here, the entire performance will be gone. Sometimes it might crash. Okay, that's what the VMs. Guys, did you understand the difference between a VM and a container? This is most important before getting into the subject. Did you understand the difference between a virtual machine and a container? Kiran, Mahendra, Vamshi.
Yeah, yes. Can you can you tell? Can you repeat once?
Okay, so what
Yes.
exactly I'm trying to say is a virtual machine is something like a full-fledged machine which will be having a dedicated operating system, okay, dedicated hardware resources, okay, and to spin up a virtual machine it takes some time because it go through the boot process of operating system, okay, operating system to start operating system, right, it takes some time, okay, so that's another thing. So you cannot create many virtual machines because it depends on like your what do you call CPU memory and all. If it is finished, like 8 GB you've used for all the 4 VMs, right? You cannot create multiple VMs because to create the fifth VM it requires a memory and all. So that's the limitation of the virtual machines. Okay. And when it comes to the containers are very lightweight processes. Again, for you these containers are like a machines. Okay, these are something like a servers only, but in the background, okay, these servers doesn't have a dedicated operating system for themselves. They use the host operating system, which is nothing but your laptop operating system, whatever you use it. Okay, but you might be thinking how it will use it. Okay, so in between them we have an engine called Docker. Okay, Docker is a software which will share the host operating system to your containers. Okay, that's how these machines will work.
Okay. Okay.
Okay,
Yeah.
so yeah, this technology introduced by the Docker guys. So I don't see any other competitor for the Docker for containerization. Let's see if somebody comes to the picture. Few people are already working on it, but this is not a complete full-fledged solution for the production application deployments, guys. This is not completely proved in the technology world at the moment. Okay, it is still in a kind of a development phase, nothing but this can be used in your local environment, not to the production. Okay, local environment, nothing but your dev, QA, all these environments. Okay, so but you cannot like you cannot rely on this for a production environment because production servers are uh, very high traffic servers, high loaded servers. Okay, you cannot put a container on the production to run an application. Okay, so this is only for the development purpose only. Okay, so come back to the containerization. Now to run these containers, okay, we would need a software, and that software is we call it as a Docker. Okay, or you can call it as a Docker engine. Okay, so you need to install a Docker engine. Okay, if you install a Docker engine, then you can create your containers. Okay, so this is a, like a story beyond like how the containerization came into the picture and who is the guy supporting this containerization. So Docker is the guy who supports the containerization, guys. Let me see if I can find something else for you. Virtual machine versus Docker. Go through these articles, you'll get to know the differences between virtual machines and containers. Whatever I explained, you can find the same stuff, but I'm just trying to find a good diagram. No, nothing is there here. Docker. So come back to the Docker. So this is what the official website of the Docker, and the documentation, whatever is provided in the Docker is the ultimate final documentation. You can't get better than that documentation. But only thing is it's very huge. Okay, going to that is really big pain. So that's the reason what I did, the important commands and all I have noted in my notes, because while going through the documentation I'll explain you the concept. Okay, concept I cannot write it by myself. I'll try to explain the concept, but what are the commands to bring up the things, right? Those things I have noted in my notes. Okay, so but these are all like copied from ultimately from the Docker website documentation only. Okay, so let me see, somewhere you can find the concept of virtual machines. Get started. They changed the website completely. This is not like used to be like this. I used to find a get started with the Docker. Okay, Docker container versus VM. I'm getting the same image, guys. Is it the same one? Yeah, almost same one. Okay, yeah. So this is a bit different. So Docker engine. Okay, so Docker engine will allow you to, like, not having the guest OS. So only the difference is you don't won't be having. Okay, this clearly explains you guys. Okay, look at this. Here you have a guest OS in the VMs, but in the containers you don't have a guest OS because these containers will share the your host operating system. Okay, but here these VMs will not share your host operating system. They have a dedicated OS. Okay, running a OS is a big pain because that utilizes the more resources. Okay, CPU, RAM, and all. So that's the reason the VMs are pretty slow compared to the containers. Containers are very fast and they're lightweight. VMs are slow and they're, like, heavy weighted because they need to go through the boot up process and all. Okay, so this should clear the difference between a virtual machine and a container. This is most important because now we're gonna work on a containers. Okay, so to work with the containers we can make use of the Docker engine. Okay, so let's try to install the Docker engine. And again, Docker engine is recommended to install on the Linux operating systems. They are supporting it from recently in Windows as well, but they recommend the Linux, guys. So let's proceed with the Linux only. Okay, so they are not much recommended for the Windows, so it's only for the Linux. Okay, so now go to the prerequisite. When it comes to the prerequisite, I would need a Linux machine. Okay, and I would need a Linux machine. Nothing more. This is what your host operating system. Listen, this is what your host operating system. Okay, so I can go with either Ubuntu or CentOS, blah blah blah, anything. So I'm going to choose CentOS because we were working on CentOS right from the day one. So let's choose CentOS, and the prerequisite is Docker supports only from CentOS 7. Remember, it supports only from CentOS 7. If you wanted to know, you can just look at the Docker CentOS 7. Okay, so look at this. To install Docker, you would need 64-bit CentOS 7, and 64-bit is mandatory. So if you want to install a CentOS operating system, CentOS 7 is a mandatory. Remember, this is what you need to download and install. Okay, so I have a CentOS 7 machine with me, guys. Okay, let's play around with that machine. I can spin up. See, again, my machine. When I say my machine, nothing but my laptop. But actually, my laptop is a Windows. Okay. So what I will do, I'll spin up a Linux machine with virtualization. Okay, and that machine I will treat it like my host operating system. Okay, you might be still thinking, like, what is the benefit by getting like this? Okay, but what is the benefit of the containers? Okay, so the benefit of the containers is why this is explored. Okay, it is easy to ship. Okay, when I say easy to ship, say my machine seems to be too slow. Just bear with me. Something happened to this. Control Shift Escape. Come on. Okay. DevOps. Containers. Sure. Okay. So now what I'm trying to explain to you is, look at this. Assume this is what your environment. Okay. And you have two servers here. Okay. And this is what your machine. Okay. Now treat it like you're a developer. Okay, so what you are doing it like your application contains two components. Okay, let's take our lead app itself. Okay, so you need to prepare a application called lead app.var. Okay, which is your front end one. Okay, and a schema.sql, which is a backend component. Okay, and these components you're trying to deploy it on two servers, right? So to deploy these applications into these servers, right, what are the prerequisites, guys? Okay, so I'm noting down everything, guys. Your server, I mean the server, the destination server should have uh, Linux OS operating system and a JVM Java virtual machine and a Tomcat. Okay, so this is for your Tomcat, and then on top of it you need to deploy your application. This is what the prerequisite. Okay, that's for your first server. For second server, when your SQL server, okay, for destination server, first requirement is it should be a Linux OS. Okay, and it should be something you should have a MySQL server installed. Am I right? Okay, and you should have a SQL account. Okay, it should create a SQL account, proper read only, I mean normal SQL account, not the router. So all this stuff should be done. These are the prerequisite I'm saying. Okay, once this is done, then you will be deploying this into these servers. Okay, and again this deployment takes place with some tool and all. Okay, instead of this, what we are trying to do it, we gonna prepare an image. Okay, what exactly an image is, we will do this lead up war, the schema.sql, everything into kind of a, we can do two images or one image. Okay, let's do two images. Okay, lead app.var is there. Okay, this lead app.var, what I will do it, I'll put it on a container. Okay, I'll spin up a container in my machine. I'll install a Tomcat. Okay, I'll install the Tomcat, and I'll install the Java JVM. Okay, and I'll deploy the lead app. Okay, everything I'm doing in my local machine itself. This is just a container. I'm running it, I'm testing it. So treat it myself as a developer. I tested, everything is good. Now my job is to, whatever I did it in my container, I want to do it on my destination server. So for that, what you can do it, you can create an image from your container. Okay, or you typically the reverse way, you create an image and then you spin up a container. Okay, I'll talk about the image container stuff later, but try to understand what I'm trying to do it is, you can get an image. Okay, so this image, what we will do it, we will store it in somewhere, some FTP server. Okay, treat it like kind of a Maven artifact, like a Nexus repository. Okay, so we will store it in some Nexus kind of a repository, this image, and whenever you wanted to deploy it into your servers, okay, what you need to do it, you deploy, and again when you're deploying it, right, this image, you don't need to have all this prerequisite, guys. Okay, you just need to have a bare metal some operating system, that's it. Okay, some machine. So what you need to do, you just have to download it here and run the container. Okay, run the image. Okay, if you run the image, whatever happened here, okay, it will immediately spin up a container, and inside the container it will run it will deploy the JVM, Tomcat, lead up, everything it will do on the fly and gives you a running lead up application. So you are avoiding a lot of scripting, okay, which you do it to perform all this stuff. So with the help of the chef, you did you install the you install the JVM, you install the Tomcat, you did blah blah blah, many things. Okay, all these things can be avoided. It's like image shifting. Okay, so what exactly you're doing, I'll try to compare the conventional deployment with the containerization deployment. Okay, so just a bar. So the conventional deployment is in conventional deployment process, what you will do it, move the artifacts, app artifacts to servers. Am I right? Move the app artifacts to servers, nothing but the var file, SQL file, you move it there. Okay, and again you run the deploy instructions on servers. Am I right? see, you log into the server and run the deploy instruction, nothing but install the software, okay, and install the, what do you call, your virtual machine and application layer, all these things you need to run it by with the help of the deployment. This is a conventional way which you already did with the help of the chef and all. When it comes to the containers, okay, with containers, right, only one step, okay, uh, run the image on server. That's it. Okay, when you run the image, you are done. Everything is taken care of by your image. Okay, so your job is to prepare this image properly on build time itself. So nothing but all these efforts, whatever your efforts you put it on, like these instructions are taken away from the server side and they built it on the here itself. So the advantage with this is, see, this is one environment. Tomorrow you have another environment. Okay, you have another environment. So you can have a number of environments. So this is like dev environment. Treat it this is, and this is like a QA environment, okay, and this is a production environment. Okay, in a conventional way, what will happen when you try to deploy the artifacts? Okay, if you try to deploy artifacts, right, something may go wrong in your instructions. So because, see, in a conventional way, the artifact you would have copied here, and the same artifact in another environment also you can copy it, but while running the instructions, right, Java version may go wrong, okay, or your artifact might be like copied wrong, or some configuration. So the VM configuration, the dev environment VM configurations, like it might be having 2 GB RAM and it might be having 4 GB RAM. It might be having something else. Okay, so you might be having some configuration issues between environment to environment. Okay, when you follow the conventional deploy, but when it comes to the containerization, right, what will happen? Whichever the environment, right, you just run the image. That's it. So there is no configuration changes you need to maintain if you try to deploy a image on the environment. So whether it is a dev environment, whether it is a QA environment, whether it is a production environment, the application is absolutely same, no config changes at all. Okay, so that's the benefit of the containerization, but it will work properly with the till the QA, all the non-environment, but production nobody tried it as of now. I mean, few people might be already tried it, but it's not proved in the production, guys, because production is a heavily loaded our environment. So that's the reason the containerization technology, like creating the images and deploying them into the servers, is mostly like at this moment is limited to the non-production environments. Okay, so now why they call this as a container? Okay, so the guy author, like who's written the Docker, right, he explained a concept of shipping, guys. Okay, let me explain you the concept of shipping now, so that it is easy to understand in a technology terms. Okay, so what exactly concept of shipping is? See, between two countries, okay, if you wanted to like ship something from this country to other country, guys, okay, from this country to other country, you wanted to like ship something, ship something, nothing but some materials, like some raw materials, like it can be food, okay, or it can be like some material, or it can be some clothes, okay, right. So what will happen if you want to try to ship this, right, okay, from here to here, you might be moving with some like a small boat, big boat, okay. In a ship, you might like keep everything in an order like this. Assume like this is what a ship, okay, this is what a ship, okay. And the food packet, okay, you might be packing this food packet, right, the food packet size is something like this size, and the material, another like some hardware material packages something like this, okay, and closed packet is something like this, okay. And these kind of materials you have like thousands of in this ship, and this ship traveled from this location to the destination location. When in the destination location, the other guy who's already receiving it, right, they need to receive the properly, like which is what, okay. They don't know which packet contains what, okay. It is really confusing for them, okay, and they cannot manage it well properly, because each and every item is in a different sizes and different shapes, okay. Maybe this is square shape, this is like rectangle shape and all. So receiving, and it is really tough for the people to like get it, okay. So now if you make this all of them maintain some consistent uh, consistent size, nothing but an equal size, like this kind of a container, okay, a big container. Whether you send food, whether you send material, whether you send clothes and all, everything is embedded in this container only, okay. So you just send the destination, you send something like a container ID, you send just an ID, you receive that container and get your items from it, okay. Whatever the material you send it to the destination, right, you send it in from a unique shape, unique size, so that at the end, right, okay, people can get the right one. Okay, and again within the ship also, the most of the space is occupied if you follow this single shape or same shape, unique shape things. I mean unique shape containers. If you keep it in the ship, right, you can mostly utilize your ship space. Okay, so most of the items you can ship it, so that's an advantage. And the receiving side also, it is really easy for them to pick it up. Why this example the author given, the same concept applies over here as well. See, leader.var is in one size. Okay, it's a different element, and your dbs file is different element, tomorrow something else. Okay, different things. If you try to ship it to your destination server, there may something may go wrong. Okay, we don't know. But if you try to package them in a base image, okay, whether you send it to this country or whether you send it to some other country, treat it like in a different environment, okay, then nothing will happen because everything is in that image. Okay, and it reflects same everywhere. Okay, whether this environment or different environment. So that's the main purpose of is comparing the uh, containers with the shipping thing. Okay, so moving this moving this container to one location or other location is called deploying actually. Okay, so now putting all these things in a shipyard. Okay, so and preparing this containers. Okay, all this done with the help of a component in Docker which is called a Docker engine. So the Docker engine, you treat it like a shipyard. Okay, so Docker engine. Okay, so in this Docker engine, you try to prepare all these images and you just send it to them. Okay, so that's a kind of a correlation he made it between the shipping concept as well as the Docker containers. Okay, so this is the story behind how the Docker containers works. So let's get into the actual topic. How do we prepare these containers? Okay, so I need to spin up a CentOS operating system, right? So we stuck over there actually. Let me do that first. Migrant. Okay, guys, CentOS 7. What is the machine name? Okay, mkdir docker host. I'm just creating a docker host directory. So here I'll spin up a machine. Vagrant init CentOS 7. Okay, and Vagrant file. Yes, CentOS 7. Now in CentOS 7, I have observed we cannot create a private network. Let's create the public network itself. Okay, and again let's try to give a little more memory, guys. For this, I'm trying to give a 1 GB memory to this machine. Or let's try to give, okay, 1 GB is enough. Now Vagrant up. Let's try to bring up this machine. So this is going to be our host machine. So here I'll show you how to install a Docker engine and how to prepare the images. Okay. So the instructions are there here. So you just follow these instructions, whatever I provided here. So in a CentOS 7 64-bit machine, you need to install the Docker engine. Installing a Docker engine is pretty easy. Just try to run this command, guys. That's it. Oh my god. Okay, to sort out this problem, right, in CentOS 7, there is a fix actually. I did it in my previous CentOS machine. Vagrant file. You need to add a line. Okay, this line you need to add it. Just remember this line, guys. Copy and open your Vagrant file. Paste it. Vagrant up. Okay, it is spinning up my machine. Okay, let it go on. Meanwhile, I'll explain some topics to you. So in Docker, you would need the Docker engine to work on it. Okay, so this you can directly install it. So the engine is something like a framework, guys. If this engine is there, then only you can work on the Docker. So in Docker, there are importantly, like, three things are there. One is Docker Docker container. Okay, the second is Docker images. Okay, and the third is registry. Docker registry. Okay, so what exactly these are all, we'll see. Okay, so first we'll see with the container. Okay, so what exactly a container is? This container is a running instance of an OS image. Okay, running instance of an OS image, nothing but it's like a computer, running with an operating system. Okay, a Docker container, you might be thinking like some box, but it's not a box. It is a engine. It is a computer. Okay, which has a computing power and which is having operating system as well. Okay, so the Docker contains operating system, guys. Okay, the Docker container contains operating systems, but only thing is a base operating system. Okay, so Docker container is a runtime object. Okay, another definition for this is a runtime object. Runtime object, nothing but when you run it right on top of your Docker engine, then you call it as a container. If you don't run it, okay, and if you treat it like a file, then that is called as image. So image, nothing but a running instance of an OS image. So a OS image is a compile time construct, a compile time object. Compile time, nothing but you don't run it. It's a static file. If a file is there, okay, you might be, guys, you might be observed, like, if you want to install a Windows 7, Windows XP and all, earlier we used to, like, copy some images, right? Did you understand what is the image? Image is a file. Okay, if you run an image, a operating system coming into the picture. Same thing here. A container is a runtime instance of an image. Okay, that's called a container. Okay, this seems to be up. Let's get into the your host. What is the command to install the Docker engine? This is a command. Okay, try to install the Docker engine. Let it go on. We'll see some definitions. I've written some good definitions. Okay, we can run Docker with no. Okay, we can run with the non-root user as well. Okay, but you can run with the root user. But mostly, like, Docker works with the root user, guys, not with the non-root user. But we can create a group called Docker group, and we can add a non-root user, and we can work with that one. But it's okay. Like, if you want, you can try that. But we'll try to work with the root user for right now. Okay. So installing the engine, I did install. So once it is installed, we can see whether it is running fine or not with the help of a command called systemctl. Cool. It's completed, guys. Okay. So try to check Docker version. So you install 1.12.5, guys. Okay. So now to check whether your Docker is started or not, okay, there is a command called sudo systemctl. I think service startup something is there, right? Systemctl, yeah. Status docker.service. So this shows, like, your Docker service is not started. Okay. To start that, run start. You can see inactive earlier it is. Okay, now you see the status. Can you see it is active now? Your Docker service is running. So Docker service is running, nothing but your Docker engine is running. Okay, now your Docker engine is up and running. Now you can perform whatever you wanted with the Docker. Okay, the first and foremost, I want to spin up a container. Okay, a small container with a base operating system of CentOS. Okay, you can do that. Docker run -it. It's interactive. And what container you wanted to spin up? CentOS, okay, CentOS container, okay, and I wanted to see the bash prompt of it, okay, bin bash. Now you might be thinking how it will bring it up, okay. So when you run this command, docker run command, right, it will download the base image from Docker Hub, okay. There is something like, for Apache Maven, it will download all the dependencies library from Apache Maven repository, right. Similarly, your Docker engine will download the base images from the Docker Hub, okay. So if you wanted to see the Docker Hub, you can just say Docker Hub, okay. Yeah, so from here it will download. So when I say CentOS, right, so search it in the CentOS over here. Sorry, let me log out, guys. See, it is showing my account. Let me log out. So this is what your Docker Hub, okay. Now CentOS, search in the Docker Hub CentOS. Can you see CentOS official, okay, and click on details. It is downloading from here now actually, okay. So it is downloading the latest version of CentOS. So it's successfully downloaded, okay. And did you see this? I have entered into my container root 908368. This is what my container ID, okay. Now I have spinned up a container. I'm into my container now, okay. See, this is the root action of your container. If you want to come out from your container, say exit. That's it. Now you're in your local machine, which is Vagrant. Did you see this? Okay. So now you're in your machine. So you came out from your container. If you wanted to see, like, what you had done earlier, right? Sudo docker ps-a. So what did you do? You spinned up this container and you exited. Okay. About a minute ago, you exited it from this container. You launched the command called bin bash. So you get into that one. Okay. Now what is the base image for this container? CentOS. Okay. So if you wanted to, like, get in again, right? You can just run the same command. Now you're in this container now, okay. So you can perform all the commands and all. This is something like an operating system. Again, it's a completely new machine. So guys, how much time it is taking to, like, getting into the machine and coming out? Not even a second. Think about, if it is a virtual machine, how much time you spend. That's what the difference I wanted to find it out, okay. So it's pretty quick in containers. Like, you can stop the container, and suppose if you wanted to stop the container, okay, you can stop the container saying, like, docker stop, okay. And what is the container ID? It's already stopped actually, okay. Paste, right. ps-a. See, it's already stopped actually. Exit and nothing, already stopped. If it is up and running, it shows up and running, okay. Now I'll show you how it will be up and running, okay. Now I logged into this, right. Try to type control PQ, okay, control PQ. Now I am back to my operating system, my host operating system, but I didn't exited there. So if you try to run the ps-a command, can you see it is still running in the background, my container, okay. 14 seconds, now 19 seconds. So my container is running in the background now at the moment, okay. So if you wanted to stop your container explicitly, see, earlier you exited, okay, exited nothing but you stopped intentionally. If you want to stop your container, sudo docker stop, and you need to stop it with the container ID. Copy, paste it. Now you successfully stopped your container, right. If you want to check, you can check it out. Can you see this? 137 seconds, 2 seconds ago it is stopped, okay. So these are, like, few basic commands, how to stop. If you want to stop your Docker engine, you can stop this. Status start stop is also there, okay. Docker version will give you which version of Docker you're using it now, okay. And to spin up a CentOS operating system, this is, see, I spin up a CentOS, right. Now I wanted to spin up a Ubuntu, okay. So see this now, run Ubuntu. See this now, it is spinning up the Ubuntu now, okay. Spinning up nothing but it is trying to download from the Docker Hub and trying to set up image, like image in my local, and I can spin up that image anytime. If I spin up, it becomes a container, okay. It's finished. Now I'm into my Ubuntu. Can you see this? It's an Ubuntu machine. It's a new machine for me. If I exit, that's it, okay. Now if you wanted to see what are all the images you downloaded, docker, okay, sudo docker images. Can you see this? You downloaded CentOS image, you downloaded Ubuntu image, both images. 10 this is last created 10 weeks ago, 47 hours ago. So these are the created dates when they updated. Okay, so the size is 191 MB, this is 130 MB, this. Okay, so these images you are trying to spin up, guys. Okay, now when I say sudo docker ps, it will show you the running containers. Is there any container running here? No container running. If you want to start a container, okay, so you can start a container by docker run sudo docker start run uh, hyphen it nothing but interactive. Okay, CentOS bin bash. So this is to run it, and control PQ. Now I'm host operating system, right? Now try to run the docker ps command. Can you see the docker ps command will show you the running containers. Okay, ps-a will show you the history, entire history. Okay, what is happening from the beginning of this docker engine. Okay, so this is a docker ps-a command, and docker images will show you what are all the images available here. Okay, and that's it. So you have one. You might be thinking, can I run the Ubuntu container as well? Yes, of course you can run the Ubuntu container. See, I want to show you one more way to run the container. Okay, ps-a. Okay, suppose Ubuntu. Where is Ubuntu? Ubuntu here. So can you see the this container ID Ubuntu? Let me see. Sudo docker start copy paste. Okay, now you see the ps-ps. You can see two containers. Can you see this? So you don't need to run always. You can already stop the container, you can start it. Okay, with the help of the docker start command. Only thing is you have to provide the container ID. Can you see the container ID E701, the Ubuntu one? Okay, so now two containers are running now. Two containers, nothing but two new servers are running at the moment. Okay, you can create n number of containers. It is such a fast, you don't even feel like it's running like a VM. Okay, but actually it is running a virtual machine. Okay, you don't feel like it is running like a virtual machine, but actually in the backend it is running a virtual machine with a different operating systems. Okay, not even a single operating system. You can run multiple operating systems. Like you can get a Fedora, you can get the Red Hat, blah blah blah, anything. So all those things are available in the Docker Hub. What are all the images you wanted to pull it? So there are n number of images are there. You just need to search what do you want. I want Red Hat. You search it. You have n number of people provide their images, Docker Hub images. Okay, so you just start to provide the name of it. So you just try to, if you try to provide this one, it will try to download that image. Okay, and once it is downloaded, we can see all those images here, Docker images, right? So these are all the predefined images which are available in the Docker Hub. Okay, now when it comes to your actual stuff, how we gonna make our own images? Okay, so till now you are downloading the already predefined image from the Docker Hub. Now it's time for us to prepare our own image, where I want to set up my Java, my Tomcat, my MySQL, my lead app application, whatever. I want to prepare my own image, and I wanted to prepare my own container. So how to do that? So that we'll see it in a tomorrow session, guys. For today, that's it. You set up a Docker engine and create some Docker containers and try to see all these commands. Then we'll see how to prepare our own images in tomorrow's session. Any questions still here? Any queries? Vamshi?
So we will be allocating space also for this.
Can you come again?
Are we allocating space? I mean, so you are installing Ubuntu image.
Okay. No, we don't allocate any space and all, because it makes use of your host operating system. When I say host, nothing but your
Okay.
whatever operating system where you're running your Docker engine, right? It makes use of that.
Okay.
Okay, if it is a virtual machine, then we have to do that, memory and all allocated for my virtual machine, right? Just now I created 1 GB. So for virtual machines you have to do that, but for the, containers you don't need to.
No, no. Okay.
Yeah. Any other queries, Kiran, Mahendra? Okay, so if you don't have any queries, then I'll just stop it for today. Tomorrow we'll see how to prepare our own custom images. Okay, thank you guys. See you all.